This video is brought to you by TrainSignal, your home for IT training products.
We're going to use 4 hosts for this example, and for simplicity's sake, what we're going to do is have each host's MAC address be the host name repeated 12 times, A, B, 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 and so forth, so we don't have to keep putting them up on the board. Also note that host A and host B are actually found off the same switch port. They're on a shared segment, and that just might become a point of contention here in just a moment. Now, when a switch is first booted up, it has absolutely no entries in its MAC address table. And one interesting fact is that the table is actually going to be built from the source MAC address of an incoming frame. Because what you might think is when a frame comes into the switch, the first thing it looks at is the destination MAC address, but that's not true. It looks at the source because that's how it builds its dynamic switching table. So we just booted the switch up. We're assuming the switch does not know off what port A, B, C, or D can be found. And what we're going to do first is assume that A is sending a frame to host C. And here comes the incoming frame, and you can see I put the source MAC destination in the arrow of all A's to indicate where that's coming from. Again, the first action the switch will take is to examine the source address of that frame. If the switch has an entry for that source MAC already, and the entry matches the port it came in on, then the switching process continues. But that's what I meant a few minutes ago when I mentioned that when you let the switch learn addresses dynamically, it can learn new locations dynamically as well. If we took host A and put it into port 20 this afternoon after the switch learned it's off port 1, when the switch gets an incoming frame on port 20 from that same MAC address, it's going to say, hey, wait a minute, something's changed here. They moved, that host has moved. So I'm going to age out the old entry and put in port 20. So again, dynamic is really the way you want to go here. If the switch does not have an entry in its MAC table for this particular source MAC address, it'll make one. And you see there on the right, I put one in there simulating the MAC table, and it's saying, okay, I know that the source MAC or the MAC address, all A's, is found off port 1. So the switch has no entry for the MAC address, it makes one, and now the switch has to make a decision about what to do with that frame. And the decision is the filter, forward, or flood decision. By filtered, I simply mean the frame will be dropped. Forwarded means it's going to be sent out the correct port for the destination MAC address, and that is unicast out that port. Or flooded, which is sending it out all ports except the one it came in on. Sounds like a broadcast, right? I mean, that's what it is. It's going to send it out every port except the one it came in on. We don't get to say never very often in networking, but there's no reason for a frame to ever be sent out the same port it came in on. It literally cannot happen. Now, here the switch has no entry for host C, the all C's MAC address. That's where that frame is actually going. So it can't be forwarded. So what happens is the frame is flooded. It's going to be sent out, a copy of the frame is going to be sent out every switch port except the one it came in on. Because again, an important bit of networking theory is that a frame will never be sent out the same switch port it came in on. Now, we have to consider what's going to happen when host C responds to host A. Now we've got an incoming frame from host C to host A. And the source MAC address of this frame is the all C's address, which we're using for host C. Now the switch first will look to see if it has an entry for the source, which is all C's, and it doesn't. So it makes an entry, and you see I put a second entry there for the MAC table that the all C's MAC address is found off port 2. So now it'll look at the destination, and it's got to make the flood, filter, or forward decision. And this time, the frame will simply be forwarded out port 1 because the switch does have an entry for the destination of that frame, the all A's address. So we've already looked at a situation where we have a flood and where we have a forward, and now you might be wondering, well, under what circumstances are we going to see a frame filtered? And I'm going to leave this particular exhibit up here. We're going to keep using this one. A switch is going to, like I said, forward a frame, or filter a frame, I should say, when it realizes that both the source and destination are found off the same switch port. So let's assume at this point that all of the hosts on this network have sent data, that the switch knows where all the devices are, and host B sends data to host A, or host A sends it to host B. Well, this being a broadcast segment, a shared segment, the switch will see that frame and it's going to see the data come in on the switch port and look at both the source and destination address, just the way we talked about it in the previous two examples. And as soon as the switch sees that both the source and destination MAC addresses are located off port 1, the switch drops the frame, because the switch knows, okay, that being a shared segment, B is going to see it anyway. I don't need to send a copy of it. I can see in my MAC table that both A and B are found off the same port. Now again, as we get away from shared segments and we get back to having the hosts in their own dedicated switch ports, which is what you see in most networks today, you don't have that much filtering going on. But you need to know when a frame is filtered, and a frame is filtered when a source and destination are found off of the same switch port. Now, that drawing we looked at earlier, we're going to go back to that for a moment. And this is a much more typical network where we have all the devices that have their own switch port. And this is an ideal configuration because here we have 4 separate collision domains, where each host is connected to its own dedicated switch port. They can all send data with no danger of collisions. Now, we still have one broadcast domain, though, because a switch forwards a broadcast by default. And the only device that we're going to talk about here in this video that doesn't forward broadcast by default is a router. But keep in mind that even though a switch will forward broadcast by default, when we configure VLANs, that cuts down on the amount of broadcast traffic in our network, because when a host in a certain VLAN sends a broadcast, only the other hosts in that same VLAN will receive it.
This video is brought to you by TrainSignal, Network Admin's #1 choice for professional IT training, where you'll find videos on Microsoft, Cisco, Linux, CompTIA, and more. Come visit us today at www.trainsignal.com.